The name of today's lesson is redundancy. What's redundancy mean? Tell your neighbors, what's redundancy? You know who loves redundancy? The military. Like the Navy. You know that on nuclear submarines that we have in the United States, there's 2 nuclear reactors. Why? Because what if one breaks? That's redundancy. Having two ways to do something is always good. You got to back up, you know? In case one doesn't want to work out or you want to make sure things are going okay, you got to back up, okay? So that's today's lesson. Because we could find our zeros, we could list them down, and we could do a sign analysis. That's one way to do things, so we understand what the graph is. Or we could understand that 3x times x cubed times x squared gives you 3x to the 1, 2, 3, 4, 5, 6 as a leading term and coefficient. This is a positive, even polynomial whose end behavior is up and up. You have another idea of how to fill out maybe some sign charts. If you got to be up and up, you're going to be positive and positive over here, don't they? Redundancy, another way to double check things so that we always will get the right answer. We could use our multiplicities to understand our bends, our bounces. We can then fill out the rest of our sign chart. And we also could double check, again, redundancy. Plug in 5. Okay, positive, positive, positive. Yeah, that makes sense. It's positive. Everything's going to work out. Change signs, don't change signs, change signs. That's it. You know, you could use the leading coefficients as well as the degree to actually fill out some of your sign chart by your end behavior. From there, you can sketch. Okay, maybe don't bend through 0, but you know what I mean. Okay, so we don't have to check our signs, or we could just think about both signs and end behavior all at the same time. Here we go. You know where the zeros are. You know their multiplicities. But you tell me, before filling out the sign chart, you could throw down 0 and throw down 3s. Tell me, what are the signs on the ends by looking at the end behavior of this polynomial? The only way we can tell what the end behavior of this polynomial is to figure out what is our leading term and its coefficient. Tell your neighbors, and this is a little tricky, and this leads us to the next page. What is the leading term with the highest degree and its coefficient? Tell your neighbors. Many of you will make mistakes. Let's see. No. I want, what is, like I said up here, 3x to the 6. 3x, x cubed, x squared. 3x to the 6 is the first term of kx. Kx is 3x to the 6 plus a bunch of other stuff. I want you to tell me, what is the first term of this polynomial? I want you to all make the mistake that you're making, which is if you say that your first term is minus 6x to the fifth, you're wrong. X to the fifth is correct. That's good. Odd power is good, but your leading coefficient is wrong. It's not minus 3 either. It is negative 24. Why? A lot of you haven't figured it out. Why?
Distribute the negative 3.
So you have this one twice. That is one distinct 0. That's another distinct 0. Got it? You got it? So this kind of leads us to the next page, and the rest of our notes is y'all need to understand what 2x minus 3 cubed is. And many of you don't know what it is. So many of you still make the same mistakes that you make as an Algebra 1 student, and you tell me that 2x minus 3 cubed is 2x cubed. That's not right. Then you're like, 2x minus 3 cubed is 8x cubed minus 27, and that's not right either. The 8x cubed is correct. If we can get the 8x cubed right now, that's good, that's fine, because we understand like 2x minus 3 times 2x minus 3 times 2x minus 3. We're going to have 2x times 2x times 2x. 8x cubed comes out of 2x minus 3 cubed. 8x cubed times negative 3x squared is negative 24x to the fifth. This is the winner. How many of you messed up on that? Because you are not comfortable distributing things to powers more than 2, especially like 2x minus 3 to like the third power. A lot of you messed up on that. That's okay. But let's finish up this problem, and then we'll get into more understanding of like 2x minus 3 cubed. You got a negative, you got an odd. Fill out your signs on your ends. Go. If it's a negative odd, what are your signs on your ends? This is your redundancy. This is your I understand end behavior. Oh, now I understand signs based on end behavior versus signs tell me what my end behavior is. We are negative x cubed. That's negative x cubed. That's our end behavior. If I'm going to the left, I go up. If I go to the right, I go down. That's telling me to the left, I got positives. To the right, I got negatives. Like, boom, I just like did my signs by understanding end behavior. Cool? Can you fill out the other signs, and can you sketch the graph? Go. Sketch the graph. Sketch the graph. Sweet. I love our beds. They're not great. Bends are tough. We got a bounce, which means my sign will stay the same. We got a bend, the sign changes. That checks out. Wood. If I don't feel comfortable with what I just did, based on my leading term, odd power, and behavior, what is our backup? What's our other nuclear reactor that could help us make sure this is correct? No. Test point. Thank you. McCarty/Ford. You could always use the test point. Plug in something like 5. Okay, negative 3 times 25 times a positive. Okay, a negative times a positive, negative. you have redundancy. You have multiple ways to check things. So that means 0 excuses, guys, to get things wrong moving forward. No excuses. Everything should be right. We bounce, we bend. Cool. But it was pretty obvious to me that you guys stink at this, and you probably stink at multiplying this and this. So the rest of the lesson is making sure you understand what the function is, the leading term, as well as the other terms. It is nice to have factored form. Factored form gives you your zeros. Yes, we can easily list off the zeros. There's 0, 3, and -2. But sometimes we want not just the leading term and the leading coefficient, but all of the terms. Linder, reasons why is like sometimes we need to add functions together. Sometimes we need to manipulate functions. So sometimes we're going to want things in standard form. Standard form is everything added together, nothing factored. Now, we can arrive at standard form through just brute distribution. And we will all practice brute distribution. Multiplying 2 things at a time, so everything's good. Now, first things first, you see this x cubed? Do you, and this is a question for all of you, and tell your neighbors, could you distribute this x cubed in so that you only had 2 things left like this? Tell your neighbors, can you do that? Tell your neighbors, can you do that? Not PEMDA. Hold on, what are you talking about? I see parentheses, I know arrows, I know distribution. Can't distribute that far over? It's a great question, isn't it? Because like this is a big mistake that a lot of students make is they see parentheses, they see something in front of parentheses, and they're like, all right, I'm going to distribute. Well, here's how I'm going to explain this. What's 2 times 3 times 4? Now, the 3 and the 4 are in parentheses. Is 2 times 3 times 4 the same as 6 times 8? Well, let's think. 6 times 4 is 24, but 6 times 8 is 48. Okay. It is not PEMDAS. It's more multiplication. You can only multiply 2 things at a time. 2 and 3 can be multiplied to get 6, and then you multiply 4. 3 and 4 can be multiplied first to get 12. Multiply that by 2, you get 24. You can't distribute this to all 4 things because what you're doing is you're multiplying x cubed twice. Don't do that, okay? So, recommendations for distributing and brute distribution is if you have one single term multiplied by 2 other terms, if you'd like to, you could distribute this into one of the 2, but not both. A times B times C is not A times B times A times C. It says A times B times C. Okay? So, feel free to do that now or later. I'm going to actually do it later. And I'm going to focus on the distribution of x minus 3 and x plus 2. Hey, are you a friend of using the box? Then do it. Use the box. It helps you. If you're like, I'm kind of past the box, Mr. Messner, fine. That's cool too. As long as when you do the math, you're going to get the right distribution of everything. X minus 3 times x plus 2 is x squared minus x minus 6. Now you can see x cubed times this one thing. You can multiply that into all of them. Cool. Having this is sometimes advantageous. The only way we can add polynomials together is to have standard forms of polynomials. Let's say I wanted to add g to f. Well, the only way to add it and simplify it is to see what g is in standard form. So let's figure out what g is. Now, the first thing we notice is there's more things going on. We got negative 2x, x minus 4, and x minus 2 squared. My advice is to don't think you know how to square things, because you don't. Write it out, and make sure you don't make the mistake of saying that x minus 2 squared is x squared minus 4, or x squared plus 4. That's not right. When in doubt, write it out. Now, to multiply this together, multiply two things at a time, just like you do with numbers. If I told you what's 2 times 3 times 4, you would do two numbers first, and then you'd multiply the third number, right? I would do two terms first, and then multiply the third term, and then multiply the fourth term. It makes sense for binomials as well as for numbers. So everybody, let's figure out what we got. Good, you got the first two, now you got to multiply that in. If you'd like to work on that negative 2x and distribute it in, fine. But you can only distribute it into one location, maybe that x minus 4. When we get to 2 things times 3 things, maybe the box is going to help us. Don't sit there and think it's going to do it by yourself. You have to do it. So multiplication finds like the area of a rectangle. Like 3 times 2 is like, what's the area of a rectangle with 3, height 2? Yeah. A nice way of distributing things so that you see that it's more than just x squared and 4 is to see that you're kind of distributing everything to everything. You're finding the area of this rectangle. That's the box.
You want to add
We'll talk about it, but we don't have to. I'm going to come around and I'm going to make sure that the people who I told to do it are doing it. And I'd like you to check all your coefficients with your neighbors. I shouldn't have to check it. You check with your friends.
Do you want us to factor out the negative 2x? No.
I did it wrong. Okay, you figured it out. Figure it out. Don't factor. No, we don't want factor. We want it distributed, just like that. Of course. There it is, right there. Negative 2x. Right? We don't want it factored. We want it distributed so we can add. Pump the brakes. Make sure that Roy Reynolds is right. Nope. Wait, negative 2. Something happened, Roy Reynolds. You got to use the box. Negative 2, 16, 40, 32. What'd you get? Oh, you got 16, 40, 32. Oh, so did you. Okay, because never mind, rocks. You're good. Negative 2, 16, negative 40, 32. All right. Now, if you didn't get that, let's say you made mistakes. Yo, the box can help you. So what I would have done is x squared minus 4x plus 4 across the top, negative 2x squared and plus 8x down the side. I'm going to use a 2x3 box. I did not do this on the homework video. I really rushed through the homework. Multiplying, be careful. Negative 2x squared times negative 4x is positive 8x cubed. Negative 2x squared times negative positive 4 is negative 8x squared. Then I got 8x cubed. I got negative 32x squared. And I got positive 32x's. What's great about the box is that you can see your like terms on the diagonal. So when you multiply everything together, or sorry, add everything together, you can just look on the diagonals to see you get 16x cubed, you got negative 40x squared, and you got a positive 32. This can be added to this, where you can see, oh, 1x to the fifth, negative 3x to the fourth, 10x cubed, etc., etc. We can't add polynomials together unless they're in standard form. Now we come to this guy. Again, the big mistake you guys made on the last page is you thought that this is just x cubed minus 8. That's not right. What's x minus 2 times x minus 2 times x minus 2? Go. What's negative 2 times negative 2? Positive 4. No, you're good. You should get 1, negative 6, 12, and negative 8. All right, good. Now, what if I told you that I could do this in brain without doing all the distribution? Because I have a different system in my head, a redundant system that can cube or fourth power, even fifth power things without brute distribution. Would you be interested? No, not right. I know that I'm going to have an x cubed. I'm going to have 3 of some things. I'm going to have 3 of other things. And then I'm going to have a negative 2 cubed. I know I'm going to have an x squared and a negative 2 there. I'm going to have an x and a negative 2 squared there. And I'm going to be able to just go and get your negative 6x squared and get your positive 12x's and get your minus 8 just like that. Would you be interested in that redundant system? I would hope yes, because it's a good thing to have as your second nuclear reactor. Okay? I know you do, Linder. I know, but you know what? Let's stretch our brains a little bit. I am about to teach you your other nuclear reactor to help you multiply binomials to certain powers. But to do this, we're going to have a little bit of fun. We are going to start multiplying a plus b by itself a bunch of times. Starting with a plus b to the 0th power. Tell your neighbors, what's a plus b to the 0th? Okay, great. Great. 1. What's a plus b to the 1st power? Okay, I'm going to write 1a plus 1b. Everybody, write down a plus b squared. You might have to use the box to get this. Write down a plus b squared. No, don't you dare say it's a squared plus b squared. No, I want you to figure it out, Woods, because you're going to be wrong. Yes, that's correct. You don't believe yourself, and I don't believe you. Do it on the piece of paper. I don't want to hear it. I don't want to hear it. Just please do it on the piece of paper. Use the box. Good. Now, this is important because we're going to use this one for all of the other ones we're going to do. We've already done a lot of work for the other ones just by doing this. Did we get a squared plus 2ab's plus b squared? Because I got 1ab plus 1ab. I have 2ab. So I have 1a squared. I have 2ab's, and I have 1b squared. Okay. Well, let's figure out what a plus b cubed is. Well, I could write this as a plus b times a plus b squared. Well, Patrick, I already know what a plus b squared is. So I can replace a plus b squared with what it's equal to, and I can distribute a plus b. Let's start that together. And then you're going to be in charge of the last one all by yourself. Okay. I will show you this with the box. A plus b times a squared, or a plus b squared. Okay. What's a times a squared? What's a times 2ab? 2a squared b. Keep going. Keep going. Good. Now add them together. Like terms can be added. How many a squared b's do you have? Add them together. How many ab squared do you have? Add those together. Cool. 2 a squared b's. 1 more a squared b. 2a squared b's. 1a squared b. 3 a squared b. Does that make sense? Yeah, I would like you to write it in the following order when you're done. Now, I'm going to put a number in front of things that don't have numbers because it'll help me. This is 1ab squared. This is 2ab squared. This is b cubed. I will write it in this order. A cubed plus 2ab squared plus 1ab squared are 3. A squared b. 2a squared b's plus 1a squared b is 3a squared b. 2ab squared plus 1ab squared is 3ab squared plus b cubed. Okay, your turn. Do a plus b to the 4th. You already know what a plus b cubed is. You could either use this and multiply it by a plus b, or you know what a plus b squared is, and you do a plus b squared times a plus b squared. What do you want to do, Patrick? How do you want to do a plus b to the 4th? All right, so you want to do a large, nice box, which is a plus b squared times a plus b squared. Whenever my cursor comes back, we can do it. So we can do a plus b squared times a plus b squared. We know what a plus b squared is, so we'll do a squared plus 2ab plus b squared, and then multiply that by a squared, 2ab, b squared. Now, you could obviously do a plus b cubed times a plus b. Or you could do a plus b squared times a plus b squared. Okay. Here we go. A squared, a to the fourth. 2a cubed b, a squared, b squared. 2ab times a squared, 2a cubed b, 2ab, 4a squared, b squared. 2ab, b squared, 2ab cubed. A squared, b squared, a squared, b squared. 2ab, b squared, 2ab cubed. B squared, b to the fourth. Isn't this fun, Ira? I love doing this stuff. Oh, the box is going to help you. So here's the correct order. I got a to the fourth. You know, I'm going to write it underneath here. I got a to the fourth plus 4a cubed b plus 1, 2, 3, 4, 5, 6a squared b squared. You're missing it, Linder. You're going to see it soon. Plus 4ab cubed plus a b to the fourth. Of course, you did this entire unit in algebra 2, so don't whine. Okay. Sorry. You didn't see it. I'm going to make sure you see it. Here were my a plus b. Now, leave some space towards the bottom for this. Either on the next page, on the side, you're going to do this. Or on the bottom, you're going to do this. Here are my a plus b. To the 0th power. 1, right? To the first power. 1a, 1b. To the second power. 1 a squared. 2 ab. 1 b squared. The third degree, you guys did this, you got 1 a cubed. You got 3 a squared b. You got 3 ab squared. You got 1 b cubed. The fourth was 1 a to the fourth. 4 a cubed b, 6 a squared b squared, 4 ab cubed, and 1 b to the fourth. You guys got that through brute distribution. But I bet you could tell me what a plus b to the 5th power would be without using brute distribution, but rather using a pattern that you've established where, 1 plus 1 is 2, 2 plus 1 is 3, 2 plus 1 is 3, 3 plus 3 is 6, 3 plus 1 is 4, 1 plus 3 is 4, 4 plus 1, okay, 4 plus 6, okay, 6 plus 4, okay. 4 plus 1, okay. 1's on the end. Could you figure it out? Yes, you can. Do it. If you can't do it, somebody at your table can do it. Go. You can do it. It's not hurting. This is just a pattern. You don't have to think anymore. You just have to look at the pattern. Go. On the bottom of your paper, right here, you're going to tell me what a plus b to the 5th is. What's a plus b to the 5th?
A to the 5th.
You know what? That's something. That is something where you can start with. Now keep going. Come on, go. Do it.
I'm tripping. Oh, my Lord.
What do you mean what? Look, the fourth degree, so it starts with a fourth power. Notice how it's like a to the fourth, a third, a second, a to the first, no a. No b, b to the first, b second, b third, b to the fourth. Yeah, so this is called Pascal's triangle. This is called Pascal's triangle. These numbers and this pattern shows up a lot in like the real world and the universe. Here is one instance where Pascal's triangle numbers show up is like a binomial to a certain power. A plus b to the fifth is 1 a to the fifth plus 5 a to the fourth b plus 10 a cubed b squared plus 10 a squared b cubed. All I'm doing is bringing the a's down while the b's come up. Plus 5 a to the first b to the fourth plus 1 b to the fifth. How do I do the coefficients? So, Swanee, I'm sorry, you didn't see the pattern. 1, cool. Think about zeros on the side. Okay, so 1 plus 0 is 1. 1 plus 0 is 1. Now, if you got two numbers next to each other, you're going to add them together, and you'll put it in between. So 1 plus 1 is 2. 1 plus 0, 1. 2 plus 1, 3. 1 plus 2, 3. Seeing it? 3 plus 3 is 6. I fill out all the other numbers, so now I'm in my fifth row. 1 plus 0 is 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 1 plus 0 is 1. You need the triangle. The triangle needs to be there, but once you have the triangle, you have what you need. For example, x plus 2 to the fourth. Well, I'm going to have my triangle. I'm going to make sure I have the 0th, first, second, third. I need the fourth degree. So here are my coefficients. Now, if you want to have the a's and the b's next to it, fine. But ready? I can do x plus 2 to the fourth without brute distribution. And here it is. I got a 1, a 4, a 6, a 4, and a 1. Now, instead of using a's and b's, I'm just going to put 2 sets of parentheses next to all of them. Go ahead. Everybody put 2 sets of parentheses next to all of those coefficients. Cool? Now, you know you got a fourth degree. So ready? On the left, we're going to go 4, 3, 2, 1, 0. On the right, we'll do 0, 1, 2, 3, 4. These are the A's and the B's. A is X, 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 X. B is 2, 2, 2, 2, 2, 2. Now we can do a little bit of work. X to the fourth plus 4 times 2 is 8x cubed. 6 times 2 squared, 24x squared. 4 times 2 cubed is 32 x's. X to the 0 is gone. 2 to the fourth, 2, 4, 8, 16. Bam. You guys on the bottom do x plus 2 to the fifth. And then we'll talk about the tough one, which is 2x plus 3 cubed. Fifth. 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. Put 2 sets of parentheses. One will represent A's and one will represent B's. Descend a power, ascend a power, and you win. Come on, go. Try it. Try it.
Okay.
X plus 2 to the fifth. Linda, what are you doing? Not doing anything.
On my leg.
Oh, gosh. We're on the bottom. X plus 2 to the fifth. We'll do the one in the middle next. We're on the bottom. I'm showing you the coefficient. The coefficient came from the triangle. Parentheses, 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 parentheses. See you later. What? Well, think about what happens when you take something to the fifth power. And we kind of did it. It's like, where did these numbers come from? Like we saw, Elander, when you took something to the fourth power, that we had fourth powers cubed first, second, 1, 3, 4. We can see that's how many A's we have. That's where the numbers come from. You saw you got A to the fourth, A cubed, A squared, A to the first, A to the 0. We had B to the 0, B to the first, B second, B third, B fourth. You see it? What do you mean? Where do they come from? It comes from multiplying things by itself over and over and over again. Yes. Ready? 5, 4, 3, 2, 1, 0. 0, 1, 2, 3, 4, 5. X in the red. 2 in the blue. X to the fifth. 10 x to the fourth. 40 x cubed. 80 x squared. 2, 4, 8, 16. 16 times 5. 60? 80. 80 x's. 2, 4, 8, 16, 32. Boom. I did that a lot quicker than any of y'all could have done that by hand. Now, Linda, I'm going to tell you something. A little secret between you and me and nobody else. We've not seen on the AP pre-calculus test anything beyond a 4. We haven't seen like a 6th power. We haven't seen a 5th power. So what do you think that means to you, Linda, for the AP pre-calculus test? We've seen like practice test questions, yeah. Yeah, practice test. So what does that mean to you, Linda?
Don't learn over 4.
Yeah, or, your first nuclear reactor, the brute distribution, like you can rely on that. That will work. Make sure that one works. And you won't have to use Pascal's triangle. But it's good to have as a backup For redundancy. Well, if it never breaks, then you're lucky.
What are great like because as it's going towards infinity, that's going to
I think they just looked at negatives and positives the wrong way.
Can you flip it back?
Yeah.
These are my grades. Because it should only be a -1. I like that though.
Is it just this one? Yeah, so, Thomas, we wanted you to list negative infinity first, okay? Thomas, take this back. Thank you. Later. So we're at third tower. Your coefficients are 1, 3, 3, and 1. Have a good one. Three, 2, 1, 0. 0, 1, 2, 3. 2x. 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 Have a good one, everybody. 3, 3, 3, 3. 8x cubed plus 9 times 4, 36x squared plus 9 times 3 is 27 times 2, 54 x's plus 8, 27 times 2 is 50. That's it. That's your backup.